All right, let's go on a little trip. An incredibly high-speed adventure, actually. We're going to follow a single piece of data as it travels from your screen, maybe halfway across the globe, and all the way back again, in literally the blink of an eye. Let's trace the journey.
Think about it. You do this 100 times a day, probably more. You click a link, you tap a button, you hit send, and boom, like magic, a web page just appears, or your message gets delivered. But what is actually happening in that tiny split second?
Well, it might feel like magic, but it's not. It's a journey, a really well-organized one, with its own set of rules, its own addressing system, and its own special vehicles. And by the end of this, you'll see exactly how it all fits together. Okay, so first things first. Before our data can go anywhere, we've got to understand the roads it's going to travel on, and that all starts with the basic idea of a network.
You know, at its simplest, a network is, well, it's just this, a connection. You need at least two devices hooked up so they can share stuff. That could be two computers in your office or a billion devices all across the planet.
Now, think of the internet world as having two main types of roads. You've got your LAN, the local area network. That's like the local streets in your neighborhood, super fast and contained. And then you have the WAN, the wide area network. That's the massive interstate highway system connecting all those different neighborhoods. The internet, of course, is the biggest WAN there is.
On this digital superhighway, there are really two main characters in our story. There's your device, your computer, your phone. We call that the client. It's the one asking for information. And then there's the server. That's the powerful computer that has the information you want. This whole setup, it's called the client-server model, and it's what makes the internet work so well.
All right, our data's ready to go, but it can't just, hit the road as one giant chunk of information. Nope, it needs to be carefully packaged and addressed before it can go anywhere. Let's dig into how that works.
This whole packing process has a name, encapsulation. And it's kind of like mailing a letter, really. Your data gets chopped up into smaller, manageable pieces, and each one of those pieces gets put inside a whole series of digital envelopes. Each envelope adds another layer of information for a different part of the trip. It's all about layers. First up, the transport layer breaks the data into what we call segments. Next, the network layer slaps on a new header with the destination IP address, and this is what creates the famous packet. And finally, the data link layer adds one last header with the physical address, creating what's called a frame. Now, with all its addresses and envelopes, our little piece of data is finally ready to hit the road.
So, the package is all wrapped up and addressed. Let's follow it on the very first leg of its journey, just getting out of your computer and to the edge of your local network, your LAN.
For this first part of the trip, the single most important address is the MAC address. Think of it like a serial number that's literally burned into your device's network card. It's permanent, and it's only used for talking to other devices that are right there on your local network.
So who reads this local address? That would be the network switch. A switch is basically the mailroom sorter for your local network. It looks at that MAC address on the frame and sends it only to the specific device it's meant for. Super efficient. It doesn't have to bother anyone else. And just like that, our packet makes it to the router. This is the big moment. This is the gateway to the wider internet. It's leaving the neighborhood streets, and it's merging onto that global superhighway.
But wait a second, here's the catch. That MAC address is totally useless out on the open internet. It's like trying to mail a letter to just Dave with no street, no city, no zip code. So how in the world does the packet find a server that could be thousands of miles away? The answer? The IP address. See, unlike that permanent local MAC address, your IP address is more like a full mailing address. It's temporary, and it tells routers not just who the packet is for, but what network, what city and zip code that device lives in, anywhere in the world.
And yep, you guessed it, the router is the device that reads the IP address. A router is like the traffic controller at a massive highway interchange. It looks at that destination IP, and in a split second, it figures out the best path to send the packet on to get it just a little bit closer to where it's ultimately going.
Okay, let's put that all together because this is super important. A switch is your local mail sorter. It uses the permanent physical MAC address to move traffic around inside a single network. A router, on the other hand, is the global traffic director. It uses the temporary logical IP address to connect different networks together. Two totally different jobs, two different types of addresses.
So after hopping from router to router, maybe all the way across the world, our little packet has finally arrived at the right network. It gets delivered to the server, but it's still wrapped up in all those digital envelopes.
So what now?
Well, the server has to do the exact reverse of what your computer did at the very beginning. It's time for decapsulation, which really is just a fancy word for opening all the mail. And it's pretty straightforward. The server just unwraps it layer by layer. The data link header gets stripped off, then the network header, then the transport header. And once that's done, the server takes all those little data segments that have arrived and reassembles them. And poof, it has your original request.
So the server finally understands what you wanted. Hey, show me this web page, and then get this. The entire process happens all over again, just in reverse. The server packages up the website's data into brand new packets and sends them on their own journey all the way back across the internet to you.
I mean, just stop and think about that for a second. How is this unbelievably complex, high-speed dance even possible? How can devices made by thousands of different companies all speak the exact same language to make this happen, billions of times a second?
The answer is pretty simple, actually. Standards. Everybody agreed to follow the same rules. And this quote really says it all. Without a common framework, a shared blueprint for how to communicate, the internet as we know it would just be chaos. It would be literally impossible. So that leaves us with a pretty cool question. What do you think is the single most important rule of the road here? The one thing you absolutely couldn't browse the web without? Is it the local precision of the MAC address? Or the global reach of the IP address? Or is it just the simple act of putting data in an envelope? Every single step is absolutely crucial, but which one do you think is the real cornerstone of our connected world? Something to chew on the next time you click a link.